Okay, so in the today's class, I will discuss about what is the need for tri-state buffer. Okay, so before discussing about decoders and encoders, this is a small topic. So you will get a question on this one. What is tri-state buffer? Ila short questions lalo ravachu. This is nothing but tri-state buffer. So what is the meaning of buffer? Yeah, buffer.
Stuck, sir.
Yeah.
Stuck.
It's not the YouTube lo unde buffering kaadu. It's like in case of this digital electronics. So buffer is nothing but whatever the input that I am giving, it is giving the as is. Okay. So there is a difference between inverter and buffer. Okay. This is your inverter, right? Yeah.
Sir.
So inverter is nothing but which is taking one input and it will do the inversion operation. That is nothing but 0 అయితే 1, 1 అయితే 0. But buffer is a circuit which is giving the exact output. Okay, exact output. So input ఏదైతే ఉంటుందో అదే output లాగా వస్తుంది. That is your buffer circuit. Okay, clear? So it's a tri-state buffer. అంటే nothing but it has 3 states. Okay, so this is if you are taking this, general circuits have input state and output state. But we have extra one more thing, that is your 3 states. Okay, this is C. Generally it is used to indicate using C. This is called tri-state buffer. This is called tri-state buffer because it has 3 states. So what is this state? Is impedance state, high impedance state. Okay, we'll discuss. Okay, so usually any logic circuit has 2 states. Yeah, that is nothing but 0 and 1. The buffer exhibits 3 states. Okay, buffer, if you are taking this buffer, tri-state buffer, it has 3 states. It has 3 pins. Okay, so generally ga manaki ఏ సర్క్యూట్ అయినా కానీ ఇలా ఉంటుంది. దట్ ఈస్ నథింగ్ బట్ ఇన్పుట్ స్టేట్ ఉంటుంది, నెక్స్ట్ అవుట్పుట్ స్టేట్ ఉంటుంది. బట్ హియర్ బఫర్ హ్యాస్ వన్ మోర్ స్టేట్ కాల్డ్ this one. This is called high impedance state. High impedance state. Okay, so yeah, so input which accepts 0 or 1. Okay, so when input which accepts 0 or 1, 0 disable and 1 enable. If 3 state control is 0, then output follows input. Okay, according to the input of 0 and 1. Yeah, so actually it is like this one. This is something like, yeah, it is A and you are having a output. You can call it as Y or F, anything. Okay, so inputs n aina undochu, but I am taking it as only one, and I am taking this C and the output, this is your output. Okay, so this C is nothing but which is the third state. Okay, which is this third state. So if this C value is 0, then output follows input. Ante nothing but output edaithe F is nothing but A annattu. Okay, 0 అయితే 0, 1 అయితే 1. అదే C అనేది 1 అయితేనేమో then it has some other state, that is high impedance state. We will discuss. Okay, so tri-state buffer. So yeah, a 3-state buffer is an integrated circuit that connects multiple data sources to a single bus. Okay, multiple data sources to a single bus. This is your tri-state buffer. The open drivers can be selected to be either a logical high or logical low or high impedance. Okay, these are the 3 states. Okay, one is logical high state. Okay, high state ante nothing but 1, and another is your logical low state, which is nothing but 0, and the next one is high impedance state. High impedance state, which is nothing but Z. Okay, so these are the 3 different state which allows other buffers to drive the bus. So it is a tri-state buffer in which we have like this. These are the input state. Okay, and this is your output, this is your input, and this is your output, and this will be depending upon on one more state called C. Okay, so that's why if the C value is both zeros, then it has nothing, no impact. Okay, no impact. That's why and C value is 1. Actually this truth table is not correct. Whenever this C, A, F. Okay, so actually this C value is 0 means it has no impact. Okay, so all of you following, right?
Yes, sir.
Yeah, So this C is nothing but one more state on it. Okay, that is nothing but three states. This is your input state, and this is your output state, and this is your intermediate state, or you can take anything. Okay, that is your one more state. Okay, that's why this is tri-state. ఈ ట్రై స్టేట్ లో ఆర్ అదర్వైజ్ యూ కెన్ కాల్ ఇట్ యాజ్ ఎనేబుల్ స్టేట్. ఓకే, ఎనేబుల్ స్టేట్. ఈ ఎనేబుల్ అనేది హై కావచ్చు, లో కావచ్చు. ఓకే, దట్స్ వై లాజికల్ హై స్టేట్ అనొచ్చు, లేకపోతే లాజికల్ లో స్టేట్ అనొచ్చు. ఓకే, సో ఈ ఎనేబుల్ స్టేట్ అనేది ఇట్ మే బి జీరో, దట్ ఈస్ నథింగ్ బట్ లో స్టేట్. ఈ లో స్టేట్ లో ఉన్నప్పుడు నాకు దేర్ ఈస్ నో ఇంపాక్ట్. దట్ ఈస్ నథింగ్ బట్ ఈ ఇన్పుట్ అనేది జీరో ఉంటేనేమో జీరో వస్తుంది, ఇన్పుట్ అనేది 1 ఉంటేనేమో 1 యాజ్ ఇట్ ఈస్ వస్తుంది. బట్ whenever this C input is high, that is nothing but enable state. Enable state లో ఉన్నప్పుడు 0 ఉన్నా 1 ఉన్నా it has some state called high impedance state. Okay, this is called Z. Z అంటే nothing but high impedance state. Impedance state. Okay, so this is the I think this is not correct, this is the correct. Okay, whenever this C input is 0, then whenever this open drivers can be selected to be either a logical high or logical low or high impedance, which allows other buffers to drive the bus. So these are the two types of tri-state buffers. Okay, yeah, so what are the two types of tri-state buffers? This is active high buffer. So active high or active low. Okay, these are the two state buffers. Okay, active high buffer or active low buffer. So active high, active low అనేది, yeah, actually what are the three different states ante you can name it as input state. This is one input state, and this is your output state, another is your enable state. Okay, so whenever we are having these three states, that is your three state buffer or tri-state buffer. Clear? All of you clear, right? Hello?
Yes, sir.
Yeah, hope my screen is visible and my voice is audible, right?
Yes, sir.
యా, సో జనరల్ గా ఏ సర్క్యూట్ అయినా కానీ మనకి టూ ఇన్పుట్స్ ఉంటాయి. ఇప్పటి వరకు మనం డిస్కస్ చేసిన అన్ని కూడా టూ స్టేట్స్ మాత్రమే. దట్ ఈస్ నథింగ్ బట్ ఇన్పుట్ స్టేట్ అండ్ అవుట్పుట్ స్టేట్. ఓకే, సో ఇన్పుట్ స్టేట్ ఆల్వేస్ ఇన్పుట్ స్టేట్ అండ్ అవుట్పుట్ స్టేట్. ఇవి కాకుండా మనకి ఇంకొక స్టేట్ ఉంటే దెన్ దట్ ఈస్ యువర్ ట్రై స్టేట్ బఫర్, దట్ ఈస్ యువర్ ఎనేబుల్ స్టేట్. సో ఇన్పుట్ స్టేట్ అనేది అంటే ఇన్పుట్స్ అంటే ఎనీ నెంబర్ ఆఫ్ ఇన్పుట్స్ ఉండొచ్చు. ఓకే, ఎనీ నెంబర్ ఆఫ్ ఇన్పుట్స్, ఇట్స్ నాట్ సింగిల్ ఇన్పుట్. సో I can take A as the input and output as, you can take anything. Okay, it's like A, B, C, D or X, Y, Z. Okay, anything. Output is Y or anything. Okay, so if I am taking output as Y, F, and enable state as C. Okay, these are the three different states. So we have input state, and we have output state, and we have one more state called enable state. If these three different types of states are there, then that is your tri-state buffer. Okay, because it has three states. So there are two types of tri-state buffers, that is active high buffer and active low buffer. So in case of this active high ante dan ardham entidante, whenever this enable pin is high, the output is same as input. Okay, so whenever this enable pin is high, okay, then the output is same as input. When the enable pin is low, then the buffer stays in the high impedance state. Okay, so I think 1 minute I will share. So this is your tri-state buffers. Okay, it is like memory. The word tri means three. Okay, it is like memory only. Buffer is nothing but which is storing the data as it is. So it is like memory. The word tri means three. Okay, so what is the meaning of tri? Means three. Normally buffer will have only one input and one output. Okay, so generally it has only one input and one output. But the tri-state buffer has two inputs, actually two inputs but one output. So that's why it is three states total. So the two inputs of the tri-state buffer are, one is the data input and another is the control enable input. Okay, that's why it has three. Okay, clear, right?
Yes, sir.
So here this is your data input A, and this is your control input, which is also called as enable input or C. Okay, and we have one output Y. So tri-state buffer can be represented as input controlled switch with an output that can be electronically turned on or off by means of external controller enable input. Okay, so a tri-state buffer can be represented as input control switch. Okay, this input will be controlled by using this control input. Okay, all of you got it right?
Yes, sir.
Yeah, so a tri-state buffer can be represented as input which is controlled by the switch or control input with an output that can be electronically turned on or off by means of this external controller enable input. Whether it is performing which operation will be depending upon the enable input. This control input can be either logic 0 or logic 1. Okay, so this is nothing but ఇప్పుడు మనకి ఒక ఇన్పుట్ ఉంది. సో ఏ ఇప్పుడు నేను ఇలా ఒక కంట్రోల్ ఇన్పుట్ అనేది తీసుకుంటే ఈ కంట్రోల్ ఇన్పుట్ అనేది నేను ఇలా పెట్టాను అనుకోండి, దాని అర్థం ఏంటిదంటే ఇట్ ఈస్ లైక్ ఐ కెన్ టేక్ లైక్ దిస్. ఓకే, సో దిస్ ఈజ్ యువర్ ఇన్పుట్ ఏ అండ్ వీ హ్యావ్ వన్ అవుట్పుట్ వై. ఓకే, సో ఈ అవుట్పుట్ వై అనేది ఈ కంట్రోల్ ఇన్పుట్ పైన డిపెండ్ అవుతుంది. దిస్ కంట్రోల్ ఇన్పుట్ పైన డిపెండ్ అవుతుంది. సో ఈ కంట్రోల్ ఇన్పుట్ ఐ థింక్ వీ హ్యావ్ 10 minutes. ఓకే, నో ప్రాబ్లం. అగైన్ రీజైన్. సో ఇప్పుడు ఈ లోపల నేను ఒక స్విచ్ లాగా అన్నట్టు, ఒక స్విచ్ లాగా ఆ స్విచ్ ఆన్ చేస్తేనే నాకు కంట్రోల్ అది ఎనేబుల్ అవుతుంది. స్విచ్ అనేది ఆఫ్ చేస్తే ఇప్పుడు ఇలా ఉంది అనుకోండి, ఇలా ఉంటే దాని అర్థం ఏంటిదంటే ఐ డెంట్ స్విచ్ ఆన్, ఇది స్విచ్ ఆఫ్ అన్నట్టు, స్విచ్ ఆఫ్ లో ఉంది. సో ఎప్పుడైతే నేను ఆన్ చేస్తానో అప్పుడు కంట్రోల్ ఇన్పుట్ అనేది ఇప్పుడు కంట్రోల్ అనేది నేను 0 అన్నట్టు, బికాస్ ఐ డెంట్ స్విచ్. ఓకే, సో స్విచ్ ఆఫ్ చేసినప్పుడు నాకు వన్ ఆఫ్ ద అవుట్పుట్ ఈస్ వన్ స్టేట్ కాల్డ్ హై ఇంపిడెన్స్ స్టేట్. Okay, the output is high impedance state. Okay, this is called high impedance state. But when the switch is closed, okay, so when the switch is closed, okay, ఇది స్విచ్ అనేది ఓపెన్ ఉంది, ఓపెన్ ఉంటే దాని అర్థం ఏంటిదంటే కరెంట్ అనేది పాస్ అవ్వట్లేదు. దట్స్ వై దిస్ కంట్రోల్ ఎనేబుల్ ఇన్పుట్ ఈస్ 0. దట్స్ వై దిస్ ఈస్ కాల్డ్ హై ఇంపిడెన్స్ స్టేట్. But whenever the control input is 1, okay, then the input is exactly acting like a buffer. That is nothing but normal. If the control input C is 1, then the buffer gate works as a normal buffer, means whatever input we have given, we will get the same as output. But if the control input is 0, then the gate is in the high impedance state. We cannot determine the output here. We won't be get any logic output here. Okay, so need for tri-state buffer. The main purpose of tri-state buffer is used to design common bus system. Okay, whenever we have this common bus. Okay, so whenever we want to transmit the data transfer anedi bus dwara jarugutundi internal ga. If you open the system, you know, right, bus. Okay, internal ga bus cables untai, bus cables which are used to transfer the data. So it is used for open collector outputs. So what are the different types of tri-state buffers? Tri-state buffers are of two types depending on the control input. They are active high tri-state buffer or active low tri-state buffer. Okay, so buffer is nothing but it has only two states, input and output. It behaves exactly opposite to the NOT gate. Okay, NOT gate ante enti manaki, yeah,
Not it.
so what is the output of this one?
Opposite of the
Yeah, so whatever the input that we are giving, it is exactly giving the inverse input or reverse. Okay, inversion. If it is 0, then you are getting 1. Ade 1 aithe 0. But buffer is nothing but it is giving the same a aithe a annattu. Okay,
Exact out.
exact output. That's why this is called buffer. Okay, so like memory, buffer is defined as the logic gate which produces the same input as it is its output. It means whatever we give as input, we get the same as output. That is buffer. So there are two important buffers are there, tri-state buffers, that is active high tri-state buffer. So an active high tri-state buffer is activated when the logic 1 is applied to its control input. ఎప్పుడైతే నేను ఈ కంట్రోల్ ఇన్పుట్ ఆర్ ఎనేబుల్ ఇన్పుట్ అనేది 1 ఇస్తానో, దెన్ ఇట్ ఈస్ యువర్ యాక్టివ్ హై tri-state buffer. Then it acts like a buffer used to store the data. So whenever it is active high tri-state buffer, then the output is exactly same as this. This is your active. Whenever it is 1, then the output is exactly same as the input. That is nothing but it is acting like a buffer. When the control input is active high, the output y equal to a. It behaves like normal buffer. But an active low tri-state buffer is opposite to the above, and it is activated when the logic 0 is applied to the control input. Control input ki C ki 0 iste, then it is acting like a active low, and then it gives to the high impedance state. it means whatever input we are giving, that will not reach the output. Okay, so this is your C అనేది కనుక 0 అయితే then it is like acting like a active low అన్నప్పుడు 0 అన్నాడు, so that's why active low ట్రై స్టేట్ బఫర్. సో దాని అర్థం ఏంటిదంటే whatever the input that I am giving, that is not giving to the output. So that's why output cannot be determined. That cannot be determined can be indicated by using Z or high impedance state. Okay, so when the control input is active low, output Y equal to Z, which is a high impedance state. Okay, all of it clear, right?
Yes, sir.
So inputs are, we have total 2 inputs, that is one is the input state and another is the enable state, and the output is only we have one output. So ఈ ఎనేబుల్ అనేది కనుక 1 అయింది అనుకోండి, ఎనేబుల్ అనేది 1 అయితే మాత్రం ఇట్ ఈస్ యాక్చువల్లీ ఎర్లియర్ ఐ డిస్కస్డ్ ఎర్లియర్ మనకి ఉన్న ట్రూత్ టేబుల్ కరెక్ట్, దట్ ఈస్ నథింగ్ బట్ వెనెవర్ దిస్ ఎనేబుల్ స్టేట్ ఈస్ హై, సో then it is exactly behaving as a buffer, that is nothing but input 0 unte 0, 1 unte 1. But whenever this enable input is low, that is nothing but 0 0. Whenever this enable input is high, this is nothing but active high tri-state buffer. Active high tri-state buffer. Whenever this input enable input is low, then this is your active low tri-state buffer. Whenever this enable input is high, then it is exactly acting like a buffer, that is nothing but normal buffer laga act avutundi, that is nothing but 0 unte 0, 1 unte 1. But whenever this enable input is low, then it is in high impedance state. What is the meaning of high impedance state? Is nothing but the output cannot be determined, that is your high impedance state. Okay,
Yes.
so all of it clear, right?
Yes, sir.
So once again I am going to this one. So yeah, this is your tri-state buffer. So what is the need for tri-state buffer? So it is mainly used for acting like a buffer. Okay, so buffer laga act cheyadaniki. So buffer ante nothing but it is used to store the data as it is. I think so whenever this enable input, this is your input state, and this is your control input or enable input, So whenever this control input, whenever this control input is 0, okay, or whenever the control input is 1, then it is exactly acting like a 1 is nothing but active high annappudu,
Yes, sir.
this F is nothing but A.
Buffer.
Okay,
Yes.
input, it is like acting like a normal buffer. It is acting like a normal buffer antene whatever the input that I am giving, it is giving the same as output, that is your buffer.
Yes.
But whenever this control input is or enable input is 0, then it is acting like high impedance state. High impedance ante I cannot determine the output. Okay, yeah, I cannot determine the output, even input anedi edaina gaani I cannot determine the output.
Sir.
So yeah,
Sir.
yeah,
అంటే డిపెండ్ ఇప్పుడు కంట్రోల్ యూనిట్ మీదనే డిపెండ్ అవుతుంది.
ante control unit పైననే డిపెండ్ అవుతుంది, that control unit or enable input. Okay,
Yes.
so in case of this active high buffer, whenever the enable pin is high, then output is same as input, like nothing but normal buffer. But when enable pin is low, then the buffer stays in the high impedance state, that is nothing but Z or high impedance state. Okay, in case of this active low buffer, active low ante dani ardham entidi, this one
0.
yeah,
Control
so
0.
yeah, control input అనేది low ఉంటుంది, that is nothing but
0.
yeah, 0 ఉన్నప్పుడు ఏంటిది, నాకు enable input అనేది low అయితేనేమో then the output is same as input. అదే enable pin is high అయినప్పుడు then the buffer is acting like a high impedance state. That's it. Okay,
Yes.
so next topic is 3 to 8 decoder. Okay, so we have the remaining topics are like decoder circuits and encoder. So manaki syllabus lo 3 to 8 decoder, that is nothing but you can directly tell as n into 2 power n annattu, n into 2
Yes,
power
sir.
n decoder. Like if it is n is 1, then we have 1 by 2 decoder. Ade n value 2 aithe 2 by 4 decoder. Ade n value 3 aithe 3 by 8 decoder. N value is 4 means 4 by 16 decoder. Okay, so
Yes.
these are the different types of decoders. Decode, okay, encode. Okay, so decoding and encoding. So a decoder A decoder is a combinational logic circuit which is used to change the code into a set of signals. That's it. Okay, decoding. So what is the meaning of decode? Already some code will be there. I will decode. Okay, decode that into some other. Okay, so decoder is a combinational logic circuit which is used to change the code into a set of signals. It is the reverse process of an encoder. Okay, we'll discuss encoder in the next class. Not in the next class, next topic. Okay, so it is the reverse process of the encoder. A decoder circuit takes multiple inputs and gives multiple outputs. In case of multiplexer and demultiplexer, okay, it will take many inputs but only one output. Clear?
Yes.
Demultiplexer is it is taking only one input but it is giving many. ఇక్కడ మాత్రం 1 అనేది కామన్. ఓకే, 1 అనేది. ఓకే, many to 1 1 to many na, that is your multiplexer. Multiplexer is nothing but many inputs will be there but only one output will be there. The demultiplexer అయితే only one input will be there but many outputs will be there. Okay, but in case of this one it is nothing but many. Okay, many to many అన్నట్టు, it is nothing but many to many. We have many number of inputs and we have many number of outputs. That is your decoder or encoder circuits. So a decoder circuit takes multiple inputs and gives multiple outputs. Okay, many inputs and many outputs. That is nothing but multiple inputs, multiple outputs. A decoder circuit takes binary data of n inputs and it produces 2 power n unique outputs. So that's why n into 2 power n. This is nothing but decoder. So n into 2 power n decoder. In addition to these input pins, the decoder has one more input called enable pin. Okay, in the same manner like multiplexer and demultiplexer has selection lines ela aithe untayo, in case of this decoder and encoder circuits we have one extra pin is called enable pin or enable line. Okay, this enables the pin when negated makes the circuit inactive. So enable pin అనేది ఏం చేస్తుందంటే when it is enable pin is activated then it will perform the operation. When the enable pin is 0 then it won't perform any operation. The circuit is active or inactive అనే అవ్వడానికి అంటే 3 to 8 అంటే 3 ఆపరేషన్ డీకోడింగ్ ఆపరేషన్ చేయాలంటే ఎనేబుల్ పిన్ ని నేను ఎనేబుల్ చేయాలి. If I don't want to make the decoding operation not to done then I can make the enable pin to 0. Clear? All of you clear, right?
Sir.
Yeah. So this is your decoder circuit. Okay, so the decoder circuit gives 8 logic outputs for 3 inputs and has one enable pin. Okay, so that's why this is your 3 to 8 decoder. 3 to 8 decoder మనకి సిలబస్ లో ఉంది 3 to 8 decoder. ఓకే, మీరు కావాలంటే 2/4 decoder కూడా తీసుకోవచ్చు. సో మనకి సిలబస్ లో 1/4 మల్టీప్లెక్సర్ ఉంది, 4/1 demultiplexer ఉంది, 1/4 multiplexer and 4/1 demultiplexer, and we have 3/8 decoder. Okay, 3/8 decoder and remaining tab is 8/3 encoder. Okay, so 3/8 decoder is nothing but which has 3 inputs. These are the 3 inputs. Okay, so these are the 3 inputs. So ఇక్కడ మీకు ఇలా ఇచ్చారంటే దాని అర్థం ఏంటంటే బఫర్ అన్నట్టు. It's a buffer. Are you clear, right?
Yes, sir.
సో బఫర్ అంటే నథింగ్ బట్ యాక్సిటీస్ గా నేను ఇప్పుడు ఏది ఇస్తానో అదే వస్తుంది. ఓకే,
Yes.
సో దట్ ఈస్ యువర్ బఫర్. అండ్ ద నెక్స్ట్ వన్ ఈస్ 3/8 decoder. All these are connected using buffers S0, S1, S2. These are the 3 inputs. And how many outputs will be there?
8.
8 outputs. Okay, so the D1, D2, D3, like this I have D7. But we have one more extra input called enable input. Okay, this is your enable input. Okay, all of you clear, right?
Yes, sir.
So enable input ganaka 1 అయింది అనుకోండి, it will do the decoding operation. The circuit is active and it will do the decoding operation. If the enable input is 0 then the circuit is inactive and it won't do any operation. Okay, so that is the use of this enable input. So the decoder circuit gives 8 logic outputs and for the 3 inputs and has an enable pin. Okay, this is the circuit for 3/8 decoder. It takes 3 binary inputs and activates one of the 8 outputs. 3/8 line decoder circuit is also called as binary to an octal decoder. Actually it is also called as binary to octal. Okay, so if it is 000 అయితే దాని అర్థం ఏంటిదంటే D0 అన్నట్టు, అదే 001 అయితేనేమో D1 అన్నట్టు. 00, yeah, actually mainly these are used for code conversions. these decoder circuits are and encoder circuits are used for code conversion, converting from one code to another code, that is binary code. Okay, so binary code ni decimal code loki convert cheyadam, or binary code ni octal code loki, or binary code ni hexadecimal code loki convert cheyadaniki we will use this code decoder circuit. Ante this is nothing but 1/2 decoder or 2/4 decoder. Okay, 2/4 decoder or 3/8 decoder, then nothing but 3 binary number ni I want to convert into, yeah, what is this one?
8.
8 is nothing but octal converter. Ade 4/16 nothing but binary number, it is used to convert into hexadecimal form. Okay, so binary to decimal. Okay, binary to decimal అన్నప్పుడు నాకు 10 ఉంటాయి, అది వేరేదండి. ఓకే, binary to decimal converter, that is nothing but BCD converter. Okay, BCD converter, that is nothing but binary to decimal converter అంటే BCD converter. సో మనకి binary to octal conversions or binary to hexadecimal conversions or binary to decimal conversions చేయడానికి we will use this decoder circuits. All of it clear, right?
Yes, sir.
So 3/8 ni ఏమని అంటారే binary to octal decoder. The decoder circuit works only when the enable pin is high. All of you got it, right?
Yes, sir.
What is the purpose of this enable pin is, if the enable pin is high, I is nothing but 1, then only this decoder will be working.
Perfect.
Decoder circuit is working. If the enable input is 0, then it won't function. All of it clear, right?
Yes, sir.
So this is your 3/8 decoder in which it is taking 3 inputs and it is giving 8 outputs, and this entire circuit will be operated based on the enable input. If the enable input is 1, then the circuit will be operating and it will do the decoding operation, which is converting these 3 binary numbers into 8 octal numbers. And if the enable input is 0, then the circuit is inactive state. All of you got it, right?
Yes, sir.
So I can say, first of all, I will take the truth table. So this is your truth table. So what are the 3 inputs? S2, S1, S0, and we have one more input called enable input. And what are the different types of outputs? D7, ఇలా రాస్తే మనం యాక్చువల్గా ఇది రాసుకోవడం బెటర్. D6, D5, D4, D3, D2, D1, D0. Clear?
Yes, sir.
If the enable input is 0, whether the circuit is active or inactive?
Inactive.
సో అప్పుడు నాకు ఇన్పుట్స్ ఏవైనా ఉండొచ్చు. ఇన్పుట్స్ XXX అంటే దాని అర్థం ఏంటంటే ఏదైనా ఉండొచ్చు, అంటే 000, 001, 010, 100 ఇలా ఉన్నప్పుడు నాకు ఇవన్నీ ఏమి ఇస్తాయి ఇన్పుట్స్?
0 sir.
అన్ని జీరోసే ఇస్తాయి. ఓకే, దట్స్ వై ఫస్ట్ మీరు చూడండి, ఫస్ట్ దానికి దట్ ఈస్ నథింగ్ బట్ ఇఫ్ ద ఎనేబుల్ ఇన్పుట్ ఈస్ 0, దెన్ the inputs may be anything, then the circuit will give only this one. Clear?
Yes, sir.
So the circuit will be operating only when the enable input is 1. So that's why enable input అనేది 1 అయినప్పుడు 1 2 3 4 5 6 7 8 కాంబినేషన్స్ మొత్తం. సో enable input అనేది 1 అయినప్పుడు 0 0 0. కరెక్ట్?
Yes, sir.
అప్పుడు నాకు ఏమవుతుంది? వాట్ ఇస్ ద వాల్యూ ఆఫ్ 0 0 0?
0 0.
యా, D0 అన్నట్టు. ఓకే, వీటిని జస్ట్ డిజిట్స్ లాగా అనుకోండి అంతే. వాట్ ఇస్ ద ఆక్టాల్ ఫార్మ్ ఆఫ్ బైనరీ? ఓకే, ఆక్టాల్ నెంబర్ ఆఫ్ బైనరీ నెంబర్ అన్నట్టు. 0 0 0 కి బైనరీ ఆక్టాల్ నెంబర్ ఏంటిది? 0. అండ్ నెక్స్ట్ 0 0 1 కి
D1.
D1, కరెక్ట్. ఓకే, నెక్స్ట్ 0 1 0 0 1 0 కి
D2, sir.
D2. ఓకే, నెక్స్ట్ 0 1 1
D3.
D3. Okay, so 0 0 1 0 0 0. Next 1 0 0
D4, sir.
D4. Okay, so this is 1 and the remaining all are zeros. And 1 0 1
D5.
D5 is, and the remaining all are zeros. And 1 1 0
D6, sir.
D6. Okay, this one. Next 1 1 1
D7.
D7 is 1 and the remaining all are
Zeros.
Okay, this is the truth table for the 3/8 decoder. Okay, so whenever they asked about anything, okay, like multiplexer అడిగినా, demultiplexer అడిగినా, encoder అడిగినా, decoder అడిగినా, ఫస్ట్ ఏంటంటే multiplexer కి what is multiplexer, what is the definition for multiplexer, and what are the different types of multiplexers, and how many inputs it is taking, how many selection lines will be there, and how many outputs it will take. And after that you have to draw the logic symbol. Logic symbol ante idi. Okay, this is your logic symbol. Okay, so this is whatever we are having, this one is your logic symbol. So after this logic symbol you have to write the truth table, and after this truth table is over, then you have to write the circuit diagram. Clear?
Okay, sir.
If they give for 5 marks, you have to explain about multiplexer and what is multiplexer, what are the different types of multiplexer, what is the logic symbol for the multiplexer, what is the truth table for the multiplexer, and what is the circuit diagram for the multiplexer. If you write also, sir. Other they specifically ask the question like write the circuit diagram of 1/4 multiplexer అన్నప్పుడు అదొకటి రాస్తే సరిపోతుంది. ఓకే, అలా క్లియర్ రైట్?
Yes, sir.
సో దట్స్ వై మీకు ఇప్పుడు అవుట్పుట్ D0. వాట్ ఈస్ D0? మనం ఓన్లీ 1 ఉన్నప్పుడు మాత్రమే చూసుకుంటాం, 1 ఉన్నప్పుడు మాత్రమే. ఓకే, సో దట్ ఈస్ నథింగ్ బట్ వాట్ ఈస్ D0?
D0
యా
enabled 1, sir.
యా,
D1.
D0 అనేది 1 ఉన్నప్పుడు నాకేంటిది, వాట్ ఈస్ ద ఎక్స్ప్రెషన్స్, వాట్ ఆర్ ద ఎక్స్ప్రెషన్స్ ఫర్ దిస్ వన్? సో D0 నథింగ్ బట్ S1 prime, S0 prime,
Yes.
S1 prime,
Yes, sir. Yes,
S2
sir.
prime. Yeah, 1 minute. Yeah, S2 prime, S1 prime, S0 prime and enable. అంతే కదా?
Yes, sir.
All of you following
Yes,
that?
sir.
So
Yes, sir.
సో ఇప్పుడు మనకి ఎనేబుల్ అనేది 1 ఉంది, అన్ని ఎనేబుల్ అనేది 1 ఉన్నాయి. అండ్ ఎనేబుల్ అనేది 1 అయినప్పుడు మాత్రమే నాకు సర్క్యూట్ అనేది ఆపరేట్ అవుతుంది. అప్పుడు నాకు D0 అనేది 1 అవుట్పుట్ ఉన్నప్పుడు నేను సమ్ ఆఫ్ ప్రొడక్ట్స్ రాయాలి. సో 1 ఉన్నప్పుడు నాకు ఏంటిది ఎప్పుడైతే సమ్ ఆఫ్ ప్రొడక్ట్స్ అనేప్పుడు 0 ఉన్నప్పుడు S2 ప్రైమ్ రాస్తాను, అంతే కదా?
Yes, sir.
దట్స్ ఇట్. ఓకే, సో D0 అదే D1 అయితే ఏంటిది S2 ప్రైమ్,
S1 prime.
S1 ప్రైమ్,
S1
S0,
prime. S1. S0.
అంతే కదా? S0 into E.
Yes, sir.
కరెక్ట్.
Yes, sir.
D2 అయితే
S1,
జస్ట్ మీరు ఇక్కడ
S2
పక్కన
prime.
రాసుకోండి 0 0 0.
Yes.
ఇక్కడ నాకేంటిది S2 S1 S0 అన్నట్టు. నెక్స్ట్ దిస్ ఇస్ 0 0 1, అందుకని S2 ప్రైమ్ S1 ప్రైమ్ S0. ఓకే,
Yes.
నెక్స్ట్
Yes,
0
sir.
1 0 0 1 0 అంటే ఏంటిది?
S1, S2 prime. S1
S0
E.
ప్రైమ్ E.
Yes.
నెక్స్ట్ D3 0 1 1, దట్స్ వై S2 ప్రైమ్
S1,
S1 S0
S1, S0 E. Yes,
నెక్స్ట్
sir.
D4 1 0 0, it is nothing but S2
S2, S1 prime.
S2,
S0 prime.
S0 E.
Next D5 1 0 1, that is nothing but S2 S1 prime
S1
S0
prime,
E.
S0
S0,
E.
Next
enable.
D6 1 1 0,
1,
that is nothing but S2 S1
S1,
S1,
1, S0 prime.
S0 prime,
next
enable.
D7, that is nothing but
1, 1, 1.
S2 S1
S2, S1, S0, enable.
E. Clear, right?
Yes,
Clear,
sir.
right?
Yes, sir.
Okay, so now based on that one I can easily draw. Okay, I can easily draw this circuit. Okay, so that's nothing but you can take this one, or I think yeah, okay, I think better I can take. Okay, so hope the whiteboard is visible, right?
Yes, sir.
1 minute. So I think you just assume like you are having this expression, so that's why. సో ఇక్కడ నేను ఏం చేస్తున్నానంటే ఎనేబుల్ అనేది తీసుకుంటున్నాను, నెక్స్ట్ S2 తీసుకుంటున్నాను, S1 తీసుకుంటున్నాను, S0 తీసుకుంటున్నాను. క్లియర్?
Yes. Yes, sir.
సో ఎనేబుల్ అనే దాన్ని నేను ఇలా తీసుకుంటున్నాను, దెన్ పక్కనే నేను ఎనేబుల్ అనేది నేను ఐ విల్ టేక్ లైక్ దిస్. క్లియర్?
Yes, sir.
అండ్ నెక్స్ట్ S2 ఐ విల్ టేక్, అండ్ నెక్స్ట్
S1.
S2 prime, and S1 I will take, and this is
S1.
your S1 prime. Next S0 I am taking, and
S1.
S0
Yes.
prime. So what is the expression for D0? So whenever this enable input is 0 అయినా అనుకోండి, okay, whenever this enable input is 0, then any value
S2.
S1 S2 S1 ఏదైనా కానీ, okay, it may be
Yes.
S1 కావచ్చు, it may be S2 prime కావచ్చు, లేకపోతే ఇట్ మే బి S1 కావచ్చు, ఇట్ మే బి S1 prime కావచ్చు, ఇట్ మే బి S0 కావచ్చు, ఇట్ మే బి S0 prime కావచ్చు. ఏదైనా కానీ నాకు ఏమవుతుంది అవుట్పుట్ అనేది
0.
0. Okay, so the output is 0. Directly I can make it as output is 0. Clear?
Yes, sir.
But whenever this enable input is high, then if it is S2 prime and if it
S1
is
prime.
S1 prime and if
S0.
it is S0 prime, then what is this one? If I connect to the AND gate,
And
then what is the output that I am getting?
D1.
Yes.
0.
D
0. Okay.
1.
సో ఈ కేసులో మాత్రం నేను ఇవన్నీ కూడా ఏం చేస్తానంటే ఐ విల్ మేక్ ఇట్ టు గ్రౌండ్. ఓకే, గ్రౌండ్ అంటే నథింగ్ బట్ 0 అన్నట్టు. ఓకే, అలా క్లియర్ రైట్?
Yes, sir.
ఐ యామ్ వాట్ ఎవర్ ద ఆల్ ద ఇన్పుట్స్ ఏవి ఇచ్చినా గానీ ఐ విల్ మేక్ ఇట్ టు గ్రౌండ్. క్లియర్? ఐ థింక్
Yes, sir.
Yes, sir.
సో whenever this hope you are following, right? So
Sir.
whenever this enable input is 0, okay, if enable input is 1 అనుకున్నప్పుడు నేను ఇది 0 అవుతుంది ఆటోమేటిక్ గా. ఇది 0 అయినప్పుడు నాకు అవి S1 అయినా S1 ప్రైమ్ అయినా S2 ప్రైమ్ అయినా S0 ప్రైమ్ అయినా ఏదైనా కానీ నాకు అవుట్పుట్ ఏమవుతుంది? I will make it to ground. That is nothing but output is always 0. But whenever this enable input is 1, okay, whenever this enable input is 1 and S2 prime, S1 prime, S0 prime అన్ని కూడా 0 అయినాయి అనుకోండి, దాని అర్థం ఏంటిది? ఇట్ ఈస్ D0. జస్ట్ మనకి సర్క్యూట్ మీకు పక్కన ఎక్స్ప్రెషన్స్ ఉన్నాయి కదా, దాన్ని బట్టి మీరు ఈజీగా డ్రా చేయొచ్చు అంతే. ఓకే,
Yes.
and next one is whenever this enable input is 1 and I am taking S2 prime
S2 prime.
and I am taking
Yes.
S1 prime and I am taking
S0.
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 Then
Yes, sir.
so what is this one?
D1.
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 Oh, hope you clear, right?
Yes, sir.
Yeah. So in the same manner we have draw this one. Okay, ఇక్కడ మనకి ఏంటంటే అది తీసుకోలేదు అసలు యాక్చువల్ గా. ఓకే, ఏది ఎనేబుల్
Okay.
అనేది తీసుకోలేదు. సో D0 కి ఏంటిది? S2 ప్రైమ్ తీసుకున్నారు, ఇక్కడ S1 ప్రైమ్ తీసుకున్నారు, నెక్స్ట్ S0 ప్రైమ్, అంతే కదా?
S0. Yes, sir.
S2 prime, S1 prime, S0 prime. Clear?
Yes.
They just took S2 and after that they took this S2 prime. Okay, so మీరు కావాలంటే మీరు you don't కరెక్ట్ గా అలానే డ్రా చేయాలని లేదు. S2 తీసుకుంటాను, నెక్స్ట్ ఏం తీసుకుంటాను నేను? S2 prime. నెక్స్ట్ S1 తీసుకుంటాను, నెక్స్ట్ S1 prime తీసుకుంటాను, నెక్స్ట్ S0 తీసుకుంటాను, నెక్స్ట్ S0 prime తీసుకుంటాను. If I connect this S2 prime and if I connect this S1 prime and if I connect this S0 prime, ఈ మూడింటిని గనక ఒకవేళ నేను AND gate కి కనెక్ట్ చేస్తే what is the output? Hello?
Ground.
Yeah?
D0.
Please.
D0.
Very good. Okay.
Ground.
So in the same manner, you can already you have these expressions, so directly you can draw the circuit. Clear? Hope clear, right?
Yes, sir.
So
Yes, sir.
this is your 3 to 8 decoder, 3 to 8 decoder. So what are the applications of decoder circuits? Okay. So always for this one, what is the circuit diagram, what is the logic symbol, what is the truth table, and what are the applications of that particular combination circuits. So what are the applications of decoders? So main ga decoders అనేవి ఎందుకు యూజ్ చేస్తారంటే కన్వర్షన్స్, కోడ్ కన్వర్షన్స్ కి యూజ్ చేస్తారు. If I want to convert the binary to octal, binary to hexadecimal or binary to decimal, then I will use this decoder. So decoders are used to input data to a specific output line as is done in addressing core memory where input data is to be stored in a specific memory location. Okay, so whenever I want to store the data in the specific memory location, then I will use this decoder. Okay, I will use this decoder if I want to store the data in the particular memory location. So each memory location will be allocated with 000. If I want to take only 2 power 8, okay, only 8 bits of memory locations అనుకున్నాను అనుకోండి, 8 bit memory అనుకుంటే నాకు ఎన్ని ఉంటాయి? మొత్తం అన్ని జీరోస్ ఉంటాయి, మొత్తం 8 bits అన్నట్టు. అండ్ నెక్స్ట్ ఆల్ వన్స్. సో ఇప్పుడు నేను ఇప్పుడు మెమరీ అడ్రస్ అనేది 0 అయింది అనుకోండి, డైరెక్ట్లీ ఐ కెన్ స్టోర్ హియర్. ఇఫ్ ద మెమరీ అడ్రస్ ఈస్ లైక్ 128, దెన్ 128 బైనరీలోకి కన్వర్ట్ చేస్తే ఏమొస్తుందో ఆ పర్టికులర్ దాంట్లో ఆ వాల్యూ స్టోర్ అవుతుంది. ఓకే, ఇఫ్ ఐ వాంట్ టు స్టోర్ ద డేటా into a particular memory location, addressing the memory locations, then I will use this decoders. Okay, so decoders are used for the addressing memory, where input data is to be stored in the specific memory location. Specific memory location lo data store avvadaniki we will use this decoders, and it is used for code conversions. Just now I have said, right? Code conversion. If I want to convert from binary to octal, or binary to hexadecimal, or binary to decimal. And high performance memory systems, this decoder can be used to minimize the effects of system decoding. It may be used for data distribution or demultiplexing ki kuda use chestam. If I want to distribute the data, then also I will use this decoder. And decoder is designed to be used in high performance memory decoding or data routing applications requiring very short propagation delay times. And decoder can be used as timing or sequencing signals in turn devices on the on or off at specific times. Okay, if I want to turn on off at specific times, alarms వాటిలలో కూడా decoders use చేస్తారు, because when the decoder inputs come from a counter that is being continually pulsed, the decoder outputs will be activated sequentially. Okay, these are the different applications of decoders. So all of you got it right? Hello.
Yes, sir.
Okay, and the next one is your BCD to decimal decoder. Okay, so till now we have discussed about 3/8 decoder. What is 3/8 decoder will do? Binary to octal.
Octal.
Octal conversion. That is nothing but 3 inputs, 0 0 0 unte, then it is decoding it as digit D0. 0 0 1 అయితే it is decoding as D1. అదే 0 1 0 అయితే it is decoding as D2. అదే 0 1 1 అయితే it is decoding as D3. అదే 1 0 0 అయితే it is decoding as D4. Okay, 1 0 1 అయితే it is decoding as D5, and 1 1 0 it is decoding as D6, and 1 1 1 it is decoding as D7. Clear? All of you clear, right?
Yes, sir.
So this is your 3/8 decoder. But now what is I am going to discuss is BCD to decimal decoder. So can anyone tell BCD to decimal? So BCD to decimal decoder, that is nothing but 4/10 decoder. You can call it as 4/10 decoder. Clear? So generally I cannot name it as 4/10 because I have only always decoder is 10 n into 2 power n, and nothing but 4/60 అనుకోవాలి. Okay, that is nothing but BCD binary to hexadecimal decoder. Correct, right?
Yes, sir.
బైనరీ టు హెక్సాడెసిమల్ డీకోడర్. బట్ మనకి ఇందులో మనం ఏం చేస్తామంటే దీన్నే BCD అంటే ఏంటిది? BCD ఆల్వేస్ BCD is nothing but 0 to 9. Correct? Is that correct?
Yes, sir.
Earlier we discussed BCD. Abhinay mute. Okay, so earlier we discussed about 0 BCD nothing but ఇప్పుడు 12 అనేది ఉంది అనుకోండి. What is the binary number for 12?
L 1100.
1100 is normal binary form లో, but BCD form లో what is 12 కి BCD form ఏంటి?
001
001 010
00
010.
ఓకే, వెరీ గుడ్. ఓకే, సో దిస్ ఈజ్ ఆల్వేస్ BCD లో మనకి ఏంటిదంటే 12 అనేది ఉండదు. BCD లో మాక్సిమం డిజిట్స్ దట్ ఆర్ దేర్ ఇస్ 0 to 9. సో దట్స్ వై 345 అనేది ఉన్నా కానీ దాన్ని ఏం చేస్తారంటే మీరు 3 కి సెపరేట్ గా, 4 కి సెపరేట్ గా, 5 కి సెపరేట్ గా రాస్తారు ఇన్ కేస్ ఆఫ్ దిస్ BCD కోడ్. సో దట్స్ వై so BCD to decimal decoder has 10 output lines. Okay, it has 10 output lines. It accepts an input value consisting of a binary coded decimal integer value and activates one specific unique output for every input value in the range 0 to 9. So all outputs are held inactive when a non-decimal value is applied to the inputs. Non-decimal values ante 10, 11, 12, 13, 14, 15. Okay, only decimal values 0 to 9 కి మాత్రమే ఆపరేట్ అవుతుంది. సో దట్స్ వై BCD లో 1010, 1011, 1100, దిస్ ఈజ్ నథింగ్ బట్ 10, 11, 12, 13, 14, 15 ఇవన్నీ కూడా వేస్ట్ అవుతాయి. క్లియర్? ఇస్ దట్ క్లియర్?
Yes, sir.
Yeah, this is like these are the 4 inputs. Okay, you can take this ABCD DBCA. Okay, like this DBCA. And what are the outputs? How many outputs are there for the BCD?
10.
10 outputs. Okay, so
10.
that's why what are
Yes.
those 10 inputs? Y9, Y8, Y7, Y6, Y5, Y4, Y3, Y2, Y1, Y0. Clear? So if
Yes, sir.
all zeros are అనుకోండి, all zeros అయితే which what is the output of this one?
Y0.
Y0. So
Y0.
Y0. So that's why Y0 దగ్గర 1 పెట్టాను. If all 0001 అన్నప్పుడు Y1.
Y1.
0010 అన్నప్పుడు Y2.
Y2.
0011 అయినప్పుడు Y3.
Y3.
And 0100 అయినప్పుడు Y4.
Y4.
And this is Y5. And this is your Y6.
Y6.
This is your Y7.
Y7.
And 1000 is nothing but Y8. And
Y8.
1001 is Y9.
Y.
Okay, so you can write in any manner. Y9 it రాసి రాయొచ్చు. So what is the expression for Y0? Anyone tell? Yeah,
D prime, C prime, B prime, A
D
prime.
prime, C prime, B prime, A prime.
A
What
prime.
is the expression for Y1?
A prime.
D prime, C prime, B
D prime,
prime,
C prime, B prime, A.
D prime.
Yes.
Y2 is
B prime.
D prime, C
D
prime,
prime, C
B,
prime,
A
B,
prime.
prime.
yes. Next,
A
D.
prime.
A.
Yeah. So D prime, C prime, B, A. Next,
A.
what is Y4? D prime, C, B
Y.
prime, A prime.
D
Right?
prime, A prime.
A
Okay.
prime.
Y5,
Yes,
D
sir.
prime, C, B prime, A.
A.
D
Y6,
prime. C prime. A.
right?
D prime. C
C,
B.
B, A. Okay.
A prime.
And next, Y8,
A. Yes, sir.
D, C prime, B prime, A prime. And
Y.
Y9,
D prime.
D,
A prime.
C prime, B prime, A.
D prime.
A. Okay.
Yes, sir.
Correct, right?
Yes.
So these are the total 9. Okay. 0 to
Yes.
9 expressions. Okay. Clear, right? So that's why you can draw
Yes,
in the
sir.
same manner. Okay. So దీనికి మీరు డ్రా చేయడం easy. Okay. So how can I draw? So just I will take D, C, B, A. So D,
A.
and I can take in this manner, and I can take C, and this is
C
your C
prime.
prime, and this is your B, and this is your B prime, and this is your A,
A
and this is your A prime. So ఇప్పుడు నాకు D prime, C prime, B prime, and next B
A
prime, and next A prime. ఈ నాలుగింటిని నేను if I connect to the AND gate, so what is the output?
Y0, sir.
Y0. Very good. Okay. So in the same manner, if I connect D, and if I connect this D prime, C prime, and B prime, and after that
B prime.
A.
A. Yes, sir.
So what is the output for this one?
Y1, sir.
Y1. Okay. In the same manner, I can draw the BCD to decimal decoder. Clear?
Yes,
Clear?
sir.
Yeah, this is your BCD to
Yes,
decimal.
sir.
So D prime, C prime, and B prime and A prime connect చేసినప్పుడు Y0. And only for Y1 ఏంటిదంటే only A మాత్రమే connect చేస్తాను. Okay. I think this is not clear. You can
Yes,
easily
sir.
draw, right? So this is your BCD to decimal
Okay.
decoder. BCD to decimal decoder, in which the expression for Y0 is D prime, C prime, B prime, A. And for this one Y1, D prime, C prime, B prime, A. Clear, right? All of you clear, right?
Yes, sir.
Okay. So
Yes, sir.
in the next class I will discuss this encoder circuit and comparator circuit. Hope you understand today's class, right?
Yes,
Yes,
sir.
sir.
So today's class we discussed about the tri-state buffer, which has 3 states. Okay. So what are those 3 states? Is input state, output state, and another is enable state. Based on this
Enabled
enable state, I can make it as buffer, normal buffer, or I can make it as a output which is high impedance state. So based on the enable input, I can have 2 types of tri-state buffers. One is active low tri-state buffer, another is active high tri-state buffer. So whenever this
High.
active low, that is nothing but C value is 0, then the output is exactly
Zero.
the output is high impedance state. Whenever this active state
Yes.
is high, then output is exactly similar to the input. Okay. So
Yes.
this is your whenever this C value is 0, then this is your active low tri-state buffer. Whenever this C value is 1, then this is your active high. Okay, whenever this is active high, then the output is acting like the input is acting like a same input ఏదైతే ఉందో అదే అవుట్పుట్ లో వస్తుంది. దట్ ఈస్ నథింగ్ బట్ నార్మల్ బఫర్ లాగా యాక్ట్ అవుతుంది. whenever this is active low, then we cannot determine the output. That is ఆ determine చేయలేదాన్ని ఏమంటామంటే high impedance state అంటారు. Okay,
yes sir.
this is your tri-state buffer which has 3 states: input state, output state, and enable state or control state. Okay, so this is called enable state or control state. And after that we have discussed about the encoder circuit. Okay, encoder is nothing, encoder. Okay, encoder or decoder? Till now we discussed about decoder. Yeah, decoding. Okay, not encoder. We have discussed about the decoder circuit. Okay, so decode, I think you know, the name itself is decoding. So decoding is nothing but whatever the code that is there, I am decoding it to 0. If the code is 011, I am decoding it to 3. If the code is 111, then I am decoding it to 7. Okay,
7.
This is
Yes.
decoder circuit which is taking n inputs and 2 power n outputs. 3/8 decoder మనం డిస్కస్ చేసాం, which is also called as binary to octal converter. And after
Yes
that
sir.
we discussed about this BCD to decimal decoder.
Decimal.
Okay, then nothing but which is 4/10 anadi. Okay, 4/10. Even if it is having 4 states and the remaining 1010 నుంచి మనకి 1111 వరకు మనము we are wasting those things. Clear?
Yes. Yes sir.
Okay then, thank you all.